Thank you for your interest in the MTSS problem-solving modules for Intervention and Progress Monitoring project. NCDPI includes 3 types of multiplication and division problems in the North Carolina Standard Course of Study. The types are equal groups, arrays in area, and compare. Each of these problem types can have unknowns in different places. We will look at each of these problem types in the next few slides. This type of multiplication and division problems involve equal groups. There is a number of groups. Each group has the same number of things, and there is a total number. An example would be, I have 8 bags. Each bag has 3 blue tiles. There are 24 blue tiles. As with addition and subtraction problem types, the unknown information can be in any one of those. Total unknown. I have 8 bags. Each bag has 3 blue tiles. How many blue tiles do I have? Group size unknown. I have 8 bags. Each bag has the same number of blue tiles. I have 24 blue tiles. How many tiles are in each bag? Number of groups unknown. I have some bags. Each bag has 3 blue tiles. I have a total of 24 blue tiles. How many bags do I have? Note that this example is with discrete objects, that is, objects that are seen as separate pieces, but similar situations can be created with measurement units such as miles, liters, hours, and pounds. Here is a measurement example. I have 8 bottles of soda. Each bottle has 2 liters of soda. How many liters of soda do I have? If you are writing equal group problems, be sure to include both discrete and measurement type questions. Consider which measurement units would be common to the grade level where the work you are doing has been introduced. For example, liters and grams are not introduced until 4th grade. You might opt not to use those units in single-digit multiplication, which is introduced in 3rd grade. No problem should involve converting measurements. The second type of multiplication and division problems involves arrays and area. For arrays, there is a number of equal rows, a number of equal columns, or an equal number of items in each row. There is a total number of items. For area, there is length, width, and area. The example here is there were 4 rows of chairs. Each row had 10 chairs. There were 40 chairs. As with addition, subtraction problem types, any part can be unknown. The total unknown. There were 4 rows of chairs. Each row had 10 chairs. How many chairs were there altogether? The number in each row can be unknown. There were 4 rows of chairs. Each row had the same number of chairs. There were 40 chairs altogether. The number of rows can be unknown. Chairs were placed in equal rows. Each row had 10 chairs. There were 40 chairs in all. How many rows were there? Area problems also fit in this problem type. Area unknown. Sonia drew a rectangle. Her rectangle was 4 inches long and 3 inches wide. What was the area of her rectangle? Length unknown. Sonia drew a rectangle. Her rectangle was 3 inches wide. The area of her rectangle is 12 inches. How long is her rectangle? Width unknown. Sonia drew a rectangle. Her rectangle was 4 inches long. The area of her rectangle is 12 inches. How wide is her rectangle? Problems in this type can also be discrete objects or measurement objects with area. The final multiplication problem type involves multiplicative comparison. As with additive comparison, a smaller and larger quantity are being compared. However, with multiplicative comparison, the 2 quantities are compared by considering the multiplicative relationship of how many times bigger the larger quantity is than the smaller quantity. Here's an example. There were 4 books on the first shelf. The second shelf had 6 times as many books. There were 24 books on the second shelf. Just like with other problem types, any of these parts can be unknown. The larger quantity can be unknown. There were 4 books on the first shelf. The second shelf had 6 times as many books. How many books were on the second shelf? The smaller quantity can be unknown. There were 24 books on the shelf. of a bookcase. The second shelf has 6 times as many books as the first shelf. How many books are on the first shelf? The multiplicative relationship can also be unknown. The first shelf has 4 books. The second shelf has 24 books. How many times more books does the second shelf have than the first shelf? This problem type can occur with discrete objects or measurement units. An example with measurement units is, there were 2 cups of water in my glass. A jug has 16 cups of water. How many times more cups of water are in the jug than in the glass?